Let's go. Hello everybody, welcome back to the channel. My name is Daniel and today we're going to be talking about 3D printing. Not only are we talking about it today, but we're also going to be making a desk away from the wall 3D printed spacer. Let me explain. So I have this really stupid issue, which is not really an issue, but it is an issue. My desk is a little cluttered, and for some things I don't necessarily have a choice. I have two monitors, I have a mic stand, and I have a second mic stand, I have two phone chargers, I have the speakers, and all of these things need to be cable managed. Alright, so if you're anything like me, it is possible that your desk is maybe not as messy, but you have plenty of things that need cabling in the back. So let me give you an example. In my case, I have a dot. I'm not gonna say the full thing because it's gonna trigger. There's the speakers, which have the cables in the back, which rub against the wall every single time the desk moves. And also, in my case, I have a microphone stand for the New Normal podcast I do with my best friend, and a few other stands. Let's say this is for the Sony when I use it as a webcam. What a great way to use a Sony. However, though, if we go in, you can begin to see that there's quite a few scratches, be it from the camera or be it from the arm when I need to twist it. And also, if we look all the way in the back, we can see that the mount rubs against the wall. So therefore, I would need something to space it and to give me more space. And if we look behind this monitor, what we will see is the external audio card, which feeds the XLR microphone. Now you can say, well, get yourself a cable management kit from IKEA, let's say, and put it underneath the desk. Been there, done that. But that's not the problem though. Some of these stands, they actually stick out behind the desk. And one of the issues that I run into, is kind of dumb, but I mean, it's an issue, is that they scratch my wall. There's nothing that keeps my desk away from the wall. There's no spacer that keeps it away from the wall. And I'm pretty sure that if I go on Amazon, I will be able to find something that is not that expensive and will do exactly what I needed to do. Where's the fun in that? I don't see it. Do you see it? And this is why today we'll be making that thing with the super long name. Desk away from the wall 3D printed spacer. Well, I have one already. Let me show it to you. Super uneventful, but it looks like this. That Sony is just way too good at tracking my face, huh? Let me give you a little bit of a background story though. When I was in my third semester in bachelor's, one of my good friends, Michael Gallo, and I decided to buy a 3D printer. Well, because we wanted to have a 3D printer. We really wanted to kind of experiment with it. We really wanted to make cool models. And most importantly, in a way, we wanted to be independent. We didn't want to have to pay crazy amounts for 3D printing when we knew that materials are quite cheap. We wanted to be able to print on demand anything our imagination can fathom. So we would print anything from our models to Christmas trees. We did that at some point too. But also a very interesting side effect of this thing became that we were able to help our classmates. Well, let's be honest, 3D printing, while quite available, if you are 3D printing, can still be pretty expensive for someone else. And it's cool, not everybody has the same financial ability. So in a way, we were able to help some of our classmates achieve their projects at different scale very quickly, very simply for the next day. So this was awesome. We even started an Instagram page and we called it the 3D Print Bros. I'm somewhat surprised this thing was not taken yet, but hey, good for us. So yes, we started 3D Print Bros where we were able to showcase some of the projects where people have done. Maybe we should have been a little bit more persistent with this one. Bah. But then that idea of helping students grew a little bit further. Instead of helping our classmates at school at McGill, we're actually able to help some students even in other universities like University of Montreal, which was quite interesting. And all of this just because of a 3D printer. It was kind of like a hot topic back then. Well, maybe still is. Maybe in a different shape. Maybe for different type of printers. But whatever, you get the idea. It's cool. Quite rapidly though, we realized that 3D printing is much bigger than we initially thought. It's not just for models, or as we would say in French, maquette. It's not just for decorative elements, something that looks amazing or that you can express some kind of creativity with, which is amazing. However, we realized that we can actually make useful stuff. Make useful stuff that you need at home, that I would need at home. And this is where we set up this philosophy, which goes as follows. I won't procure it unless I cannot make it in a relatively quick fashion that takes less than a week. We will never purchase anything online or off of Amazon if we can make it. If we can design it within a week or two and we can 3D print it not only on the cheap, but custom to our particular needs, we'll just 3D print it. Now let me give you just a few examples of things I was able to 3D print at home, sometimes designed, sometimes downloaded off of the internet. So this would include an iPad stand, memory card holders, clamps. Yes, clamps for my maquettes, which is a microphone stand, a tripod head, because at some point when my best friend and I started our podcast, I just had my phone and I needed a way to attach a bunch of like lights or a microphone onto it. And again, I just didn't want to spend the money. And also it was a cool project. Headphone stands, and even what we're doing today, that spacer. Oh, and let's not forget a bunch of Voronoi elephants, because my mom likes elephants. So yeah, Voronoi elephants, that's it. But now you can ask yourself the question, why spend so much time trying to design something when you can buy it easily and because it's readily available, maybe off of Amazon? On Amazon, some things cost 5 to 10 bucks. Let's say a tripod head, my goodness, you can find that for the cheap. Why would you design it? Why would you want to make it custom when you can buy a bunch of connections and your total is not going to be even 20 bucks? Well, I'm so glad you asked. And this time I'm going to tell you. And let's start with the first reason, and that is cost. And I really want to get cost out of the way because I think that sometimes money taints the bigger ideas. So even when it comes to materials, one spool of PETG or PLA, it's around 30 Canadian dollars. This is for 1 kilogram and you can make plenty of things. Factoring electricity and something like this, please focus. Anyways, and something small literally costs you $1 or 50 cents to produce. And it's also custom. So money out of the way, let's keep going. Well, maybe one of the biggest reasons for me to create something from scratch is that I have to analyze a problem. I really need to figure out what the problem is, what the path is, and then what the solution would be. And that's kind of interesting. The other thing is that it really forces me to learn stuff, eh? It forces me to learn software, it forces me to learn about materials, like why would I use PLA or why would I use PETG and why would I use ABS? You will never use ABS. Also, by designing something from scratch, you really give yourself the opportunity to discover something along the way. Maybe you jump into a project thinking that you know everything, right? Because you imagine the whole process and you tell yourself, okay, so I'm going to design this and then that, and then I'm going to export the STL file and then I'm going to send it to the 3D printer, good to go. But then you will discover that there's 7 other things that need solving along the line, which means that now your single-faceted problem becomes a multifaceted problem, which means that you have to come up with a multifaceted solution. And this is fucking exciting. And let me tell you, this world needs problem solvers. So in a way, if you put yourself in a position where you have to solve a problem, even though you created the problem, and you have to come up with a solution that you don't necessarily know, so you have to spend time researching or trying or sketching or figuring it out, that makes you a better problem solver. And you do a bunch of projects like this, well, now you are better at solving problems, and trust me, people have a lot of problems that need solving, so that makes you better. And also one added bonus is that watching 3D printing is kind of mesmerizing, to be honest. Even to this day, I've 3D printed so many things, just watching it come to life out of nothing, sign me up any day. I'll take it. And it's kind of funny because I know I've wasted maybe 20 minutes watching something print and it's such a waste of time, but it's so freaking good. Enough of me rambling, let's jump into the design process. The way we're gonna operate is we're gonna start with a sketch, just kind of understanding the broad terms of what I want to do. And then we're going to move into software. In my case, I'm using Rhino. I know that some of you out there might say, 3D printing, you're designing a part, use Fusion 360. I know, but I've purchased a license for Rhino 7, so Rhino 7 it is all the way. And once we're done with modeling with Rhino, then we're going to put it in Prusa Slicer because I'm using a Prusa printer, and then that's it. Then we're gonna watch it print, and then we're gonna watch it being used in real time. Anyways, see you on the flip side. Bye. All right, let's start with the basics. And I said that I have 3 criteria, right? So one of them would be cable management, parametric, do not damage the wall. All right, so these are my 3 criteria, all right? And it it looks fucking awful. Okay, let's do this. So the initial sketch goes as follows. We have the desk, which is somewhere here. And we also have the wall, which sits somewhere there. Okay, perfect. Now the question is, what do we do with that space in between? And how big do we want it to be? In my case, I think I will go slightly overkill and call this 5 centimeters. So 50 millimeters. Perfect. Now, I would like geometry to be done in such a way where you can just select a bunch of vertices and stretch it so that you can regulate what the distance between the desk and the wall is. Maybe you need 2 centimeters, maybe you need 5, or maybe you need 10 for some reason. My goodness, what is behind your desk? Or maybe you just need it to be spaced this much, you know? And one thing that I would like to avoid is seeing it from the top, or at least having another item on top of the desk, which means that if I zoom in here, everything needs to happen underneath. So it needs to sit somewhere in here. So having said that, one of the simplest things that come to mind would be just a straight line, maybe go up so that the force is being transferred this way, using a singular screw and nothing more. Something that goes like this, hits the wall, and comes back down. At the same time, because I want to be able to put the fixer, this little thing from IKEA, this is this is the reason why we're doing this thing. So if we just make it out of plastic and there's nothing soft on the end, it's scratching the wall again. So therefore, we need to be able to attach something soft, fluffy, fuzzy, whatever. Anyways, you get it. And I think that the best thing to use would be one of these furniture scratch prevention things. I have the IKEA fix in front of me, this thing. I can either make it a flat surface and just stick it on top. However, though, this is going to be prone to shear. Or what I can do is I can create like a little socket for it so that it can sit within the socket. So if it ever moves from left to right or from up to down, it is in a way sequestered within this socket. So I think I'm going to keep it this way. Now, also we spoke about cable management, and this can be expressed in something as simple as a hook. However, if I put it, let's say here, and if I run my cables there, that means that I'm creating a lot of torque because I have all the weight at the end. So that means that maybe I can design that hook to sit either right underneath the screw, which is also not a great idea because I need to be able to screw it in somehow. So if it sits in here, it's going to prevent me from doing this, or at least it's going to make it very difficult. So what I might do is I might kind of create myself a barrier where I can put my screwdriver like this. Oh my goodness, it's the ugliest screwdriver ever. But at the same time, it will not be too far away from the anchor point, which is going to reduce the torque. So what I'm going to do, I'm just going to imagine that it sits somewhere here, like this. So you can put cables like that. All right, perfect. Now, this as an initial sketch looks pretty okay. However, though, there's a lot of materials that we can get rid of. For instance, all of this, I could not just leave it solid. This is just a waste of material. So what I could do is I can empty it out by doing something like this, so that only this is a solid material and the center is empty. Now, what is interesting is by doing this, I can actually put some cables through. Yes, I cannot take them out easily this way, but nothing prevents me from kind of putting them through at the same time. Let's say cables that I know are going to be more permanent. Let's say the XLR cable for the pod mic, or some of the audio because I know I'm not moving away my speakers. So let's say, let's remove this or fade it up. Let's go to our drawing assisted layer and try to figure something out. Boom, boom. No, I'm just gonna do it like that. Probably in this area, it would need some good thickness, something like maybe 2 millimeters so that it's sturdy enough. We have the hook, which is going to look something like this, I suppose. And then we continue this straight just for the ease of it. And then, as we said, now what is interesting is I would like to keep this, maybe I can use a different color for this one. I can use this line and indicate that I want it to be continuous, meaning that if I go in the assisted layer again, and if I kind of eat too much from it, it's maybe not a bad idea. It's not a good idea, sorry. So I'm going to kind of continue this solid material straight. So therefore, I'm gonna eat up my space like this. And voila! There's something else which is interesting is that if I'm anchoring it here, I don't necessarily need all of this area in the back. However, for torque purposes, I am imagining if I have a pin here and I have the member like this, so it's pinned like that, and because you have the weight of the cables and the weight of itself on the right side trying to push down, well, this side is going to try to push up. So then actually to the contrary, maybe having this tail, let's call it a tail, here would be beneficial because it will be pushing against the desk on top. Now, we know that the desk is exactly 17 millimeters. Thank you, IKEA. And we know that this side, we said we wanted to have it 50 millimeters. I would say that the thickness of this member here should be not more than 2 millimeters. And now I have another issue. Because this is 17 millimeters, it requires quite a short screw. Turns out that I don't have one at home. And what I'm afraid is that if I screw it in, I can puncture it through. Now, my way to combat this would be to focus on this area here and make it a little bit thicker. So what I can do is a little bump. Oh my God, this is ugly. But you get the idea. Can make a little bump so that when the screw goes in, I'm actually safe when it comes to puncturing through the top of the desk. So I'll maybe do this at, I don't know, 4 millimeters. And in this way, I am sure that I'll never puncture through and have just like a screw sticking on top. All right, amazing. So that means that our piece, in the simplest possible terms, would be this. Again, nothing fancy. And I think that this is one of the beauties of 3D printing, is that you don't have to go fancy every single time, especially for a piece that will never be seen. Now, what would be an interesting exercise to do is to run it through generative design in order to minimize the amount of material we use. But then again, there's not many loads applied onto this piece. So I'm fairly confident that the way it looks right now would work pretty flawlessly for what we want to do. And also by having it a little shorter, but then again, I'm not sure because it depends how thick this piece is. It might be a little higher, but if it stays the way it is, my eye might not be able to perceive it. So this is great. Or if not, if it actually goes all the way, I might be able to see it a little bit, but then at the same time, how often do I look there? And if I have only two, which sits on the two ends of the desk, meaning that if I draw the desk in plan, the desk is something like this. If I have one piece here and one piece there, possibly a third one, which I doubt it, I already have speakers on this side, a sound card on this side, and if I'm in the middle, I might never be able to see it, which is great. Okay, let's move into Rhino, model this, and send it to 3D print. Alright, so here's the result. This is what it looks like. So let's investigate it. We have the little nook, if you wish, the little socket where our soft IKEA fixa would stay in, and it would be kind of sequestered so it wouldn't be able to move up and down. We also have this negative space in the middle where I will be able to pass cables through. And there's also the space at the bottom, which is just another cable carrying thing. Now, it feels a little too flimsy, but at the same time, I'm not that worried because cables are not as heavy and it's pretty good. And at the same time, we also have the little bump with the hole for the screw. and the tail, which is going to counteract the moment as this thing is trying to sway this way. Also the hook, again, it's very close to the anchor point in order to minimize the torque. And if there's any torque really, it would be generated by any cables that are happening within this area. In my particular case, I wouldn't have any. Also, what is nice is that because this is a long piece, you can kind of select only these vertices in the 3D model and just kind of push them to the left if you want to have less space. But yeah, this is what it looks like. It is extremely simple. And let's assemble it. Get out of here. Let's take this. So I kind of measured it so that it fits perfectly inside. Please tell me you're in focus. Yes. All right, this is perfect. And as you can see, it surpasses the lip just by a little bit, which is perfect. And let's say if I slam it against the desk, we'll be able to see if this was a success. Versus the plastic. All right, success in my books. All right, let's take a look as to what it looks like. Boom. I'm actually pretty happy with it. I ended up putting it aligned with the top surface just so that I can have enough space for the IKEA fixer in the front, just because I just want to make sure that this space was enough. But to be honest, I'm pretty happy with the way it looks. And as you can see, the hook underneath. So I just have this cable next to me and let's see how it goes. So I can either go and wire it through here or, oh boy, I can wire it through down there, through the hook. And honestly, I think that this is perfect. Now, the only thing we're left to do is to put it in the back of the table and see how it goes. Since we gotta lay down on the floor, I think I might have effed up. Remember when I said that having it 5 centimeters long, meaning that the desk would be 5 centimeters away from the wall, might be a little bit too much of an overkill? No, it is an overkill. The funny thing though, it's just enough for the microphone stand, but for everything else, it just seems like I can lose stuff there pretty easily. Listen, unless you have something very wide behind your desk, I would say maybe stick to 2 centimeters, just so the cables can go through freely. Besides that though, I count it as a success. Let me show you the result. It's pretty smooth, uneventful, but I think this was the whole purpose. All right, let's go. All right, let's take a look at the result. And as you can see, it looks pretty good to me. Make sure it's focused. And if I push the desk, boom. So as I was telling you, it might be a little bit too much of a space behind, but you know what? I'm just gonna live with it and I'm just gonna be more careful. To be quite frank with you, I really hope that this video was helpful to you, or if not, at least entertaining. I would be extremely curious to know if you use 3D printing to create some useful stuff around the house. And if yes, show off. Show off in the comments below. Let us know, what is it you do? If you have it posted on Instagram and you want to show us, or you want to just show off. Show us in the comments below so everybody else can see. Actually, it would be super cool if the comments is a place for creators to meet other creators and to show off their work and comment on other creators' work. Imagine how cool that'd be. Yo! Use this video to show off your work. I want to see your work. As usual, I'll make the files available in the description below. You can download them and use them. Have fun. And if you ever 3D print them, let me know. I just want to see it. I just want to see it in use. Imagine if I design something that you can use and everybody else can use. And actually, there's at least one more person using it at home. Love it. Cheers to that. I'm gonna see you in the next one. Oh, you're typing to tell us what is it that you made using 3D printing at home. Okay, then it's fine. I'll be here with you this entire time. Sounds good. Cheers to that. Oh no, you did that? You made it? Oh, that's amazing, man. You should put it online and share it with everybody. Yeah, because if you don't, you're a bitch. I cannot say this on YouTube. You're a little bitch. As a YouTuber who just started, any type of support helps. So if you like this video, hit the like button. If you want something to say, please leave it in the comments below. I'll be absolutely happy to answer. And if you didn't like it, well, that's just too bad. But you know what? You can do it. You can hit the dislike button twice. Well, let me tell you this. Let me just read from my I suppose I'm gonna read from my diary. Well, oh, people have Samsungs nowadays.